Have you ever wondered how the universe works at its most fundamental level? Like, what are the rules that govern everything from the smallest atom to the largest star? That's where thermodynamics comes in. It's a branch of physics that deals with energy and how it transforms and moves around. It might sound complicated, but trust me, it's fascinating stuff. Thermodynamics affects our lives in countless ways, even if we don't realize it. From the engines in our cars to the refrigerators in our kitchens, the principles of thermodynamics are constantly at play. Understanding these principles gives us a deeper appreciation for the intricate workings of our universe. In this exploration of the cosmos, we'll journey through the 4 laws of thermodynamics. Don't worry, I'll keep it light, fun, and easy to understand. We'll use everyday examples and maybe even blow some stuff up. Metaphorically, of course. Fasten your seatbelts, space cadets. We're about to embark on an exciting adventure into the heart of thermodynamics. Before we dive into the laws themselves, let's talk about energy. Energy is everywhere and in everything. It's the ability to do work, to make things happen. Think about it. You need energy to move, to breathe, to think. Your phone needs energy to send text messages, and your car needs energy to drive. Even a tiny seed needs energy to sprout and grow into a plant. Energy comes in many different forms: heat, light, electricity, motion, and even stored energy like the chemical energy in food or gasoline. The key takeaway here is that energy is never created or destroyed, only transformed from one form to another. And that, my friends, brings us to our first law of thermodynamics. The first law of thermodynamics is all about energy conservation. It simply states that energy cannot be created or destroyed, only converted from one form to another. Imagine a car engine. When you burn gasoline, the chemical energy stored in the fuel is converted into heat energy, which in turn is converted into mechanical energy that makes the car move. The total amount of energy remains the same, but it changes forms. The same principle applies to a battery. A battery stores chemical energy, and when you connect it to a device, that chemical energy is converted into electrical energy, powering your device. The first law of thermodynamics is a fundamental principle in physics. It helps us understand how energy flows and transforms in the universe. It also has important implications for things like energy efficiency and sustainability. Now, let's talk about the second law of thermodynamics, which introduces us to the concept of entropy. Entropy is a measure of disorder or randomness in a system. The second law states that the total entropy of a closed system can only increase over time. In other words, things tend to become more disordered and chaotic. Imagine an ice cube melting in a glass of water. The ice, in its solid, ordered state, has low entropy. As it melts into liquid water, its molecules spread out and become more disordered, increasing entropy. Here's another example. Imagine mixing hot and cold water. Initially, you have 2 distinct regions of different temperatures, low entropy. As they mix, heat flows from the hot water to the cold water until they reach a uniform temperature. This mixing process increases entropy because the final state is more disordered than the initial state. The second law of thermodynamics is why time seems to flow in only one direction, from past to future. It's the direction of increasing entropy, the direction of increasing disorder.